right, I'm going to try and go over CCC word hunt as quickly as humanly possible. So, first order of business, hopefully you've figured out what the problem is and why you're here. So, first order of business is getting in the input. So, it looks like we need to take in the word, number of rows, number of columns, and then the grid. And it's the letters in the grid. So they should be separated by single spaces. Cool. All right, let's do it. So we will go here, and first thing we got to grab the word. I'm gonna want it as a char array just because I feel like it. I'm probably going to want to access it everywhere, so I'm going to make it static, so it'll be accessible by all static methods. So char array, I'm going to call it the word because that's what it is, and then I'm going to need a scanner. So bam. So I got my scanner, and first thing is the word. So I'll say, hey, word is just equal to the scanners.next, because that'll grab the next word, and then to char array, because that is a lovely string array that just converts it to a char array, which will just make things a little easier for me. All right, now I have the delightful bit of getting the rest of it. The rest of it's pretty easy. Yeah, maybe I'll throw in here rows. So I'm getting number of rows, number of columns, and then I'll just say, hey, num rows equals input next int. Grab that. Num calls equals input next int. So I just made them static, so I got a reference, static reference, so if I have any other methods, like say, is it in bounds or whatever, which I'm probably going to want, then I don't have to like pass num rows and num columns and make it annoying. So next, I'm going to want this, I feel like having it as a char array. You can do it as a string array, whatever you want, but I'm going to do it as a char array. It does appear that everything is space separated, so working under that assumption, I will make my little char array. So that is, I'll call it my grid maybe, equals new. Oh, this should also probably be static ref grid. Just so I can access it from other methods without bothering to pass it. Keep things a little light. So I'm going to say it's a new char array with the number of rows and the number of columns. So it's pretty nice. Then I just got to do double for loop, get all this junk. I'm going to do kind of an easy way. It's not super efficient. Rows R++, so double for loop. So I loop through every bloody letter and the associated indexes. And then I'm just going to say grid RC. That entry is just equal to input next int, because it's supposed to be space separate, or not, sorry, not next int, dot next dot char at 0. Because theoretically, I can treat all these little letters as separate words and just do next int to grab this letter, and then the char at 0, index 0 is just the letter as a char, and so that's just a way to grab all of them and convert them to chars. because I find chars a little easier to work with. You can keep them as strings if you want. It's just a preference thing. Okay, now I got all the data. Now I got to have my strategy. Now, my initial strategy will be basically how I normally do word searches, which is I'm just going to go through it and look for the first letter. Oh, look, I found M, and then I'm going to cycle around it and look for the second letter, and if so, I'm going to take off in that direction. So here's doing that. So I can basically copy and paste this code, because again, I need to double for loop through my grid. And then I've got to look for the first letter in the word. So I'm just going to say if grid RC is equal to the first letter in the word, then I'm going to start my next bit. I'm going to start looking around it. So I'm going to do another double for loop. Exciting, exciting. So this will be for, I don't know, I is equal to -1. I'm going from -1 to +1 because those are the shifts around it. I'm basically going to have I be my row shift. It's either going to be, I'm going to be looking on the row above it, the current row, or the row below it. Anyway, so this is going to be my row shift. I is less than or equal to 1. And then go up by each one, and then I'll do the same thing with my...
Do you mind if we open the wall in here just for tomorrow?
Okay. All right, and then we'll do our column shift. J equals -1. J is less than or equal to 1. J plus plus. So we got all our little shifts here. If R plus I why don't we start with no point in checking if the second letter is the first letter. Honestly, we don't need that check because we're guaranteed that all the letters in Word are distinct. I'm going to throw it in there just in case I want to do it with a word that could have like 2 of the same letter, which is fairly common. So I'm just going to say, hey, if I does not equal 0 or J does not equal 0. So one of those has to be true, just so it's not 0, 0. So that's just checking that, because I'm doing a grid kind of around the first letter, but I don't want to start looking for the second letter right where the first letter was with a shift of 0, 0. So that's just getting rid of that. So don't worry about it too much. You don't actually need it for this question. All right, we also need it to be in bounds. So we need the R plus I to be in bounds and the column plus J to be in bounds, because that's going to be our next space. That's going to be where we're looking for the next letter. So it's got to be in bounds. We don't want to look outside of our grid. Eons. Let's also double check that the grid at R plus I is equal to the second letter, column plus J. So if that's equal to the second letter, which will be a word 1. So that's our second letter. Then we want to make a big old recursive method to add to our count. By the way, we probably want to have a count variable that we will eventually return. I'll start it at 0 and add to it. I'll just call it recur just for fun. So I'll say count plus equals recur. Now, we're basically done, except we gotta make two methods. So I'm gonna make a inbounds method. I'm using IntelliJ to make it a little easier. I'm just gonna call this R and C. So I'm gonna return, hey, R is gonna be greater than or equal to 0, and R has to be less than num rows. And C has to be greater than or equal to 0, and C has to be less than num columns. So nice and easy, just so I don't have to use this a bunch of times. I made a little method. So that's that one. Now we just got to make recur. Now let's think about what we're going to need here. So we are going to need the current index of the word, which will be 1. So we'll be looking at index 1 of the word. That's the thing we're currently starting at. We are going to be, so we're going to need that index, we're going to need the row, and we're going to need the column, like a current thing, though currently that would be R plus I and C plus J. So these are the coordinates of the second letter. We found the first letter, and then we found the second letter around it, and then we're like checking from there. So the coordinates of the second letter is R plus I and C plus J. And then we also need some way of recording the current direction, which I'm just going to use I and J. Because they let me know the direction. If it's moving to the right, J will be 1 and I will be 0. If it's moving diagonally down and to the right, these will both be 1s. If it's moving diagonally up and to the left, these will both be negative 1s. If it's moving up, I will be negative 1 and J will be 0. It's just a like shift each time going to the next letter. This is the row shift and this is the column shift. And then because it needs to be able to turn right or left, but only once, we're also going to need a Boolean saying if we've used our turn yet. Like we're allowed to turn right once, so I'm going to say, hey, that's my used turn thing. So I'm going to create my recur method, and then I just got to label all these so it's not I plus 1. So first one is the index of word that we're working through. Second one is kind of like our current row. Next guy is our current column. Next guy is our row shift. IR shift, that's not useful. And next guy is our column shift. Next guy is whether we have used our turn. All right, now we just got to fill that in. So it's going to be a little recursive method, so it's going to call itself a bunch. We need a base case anytime it's a recursive method. So if the index is equal to the word length minus 1, and I guess we will only recur if the next thing is there. So if we get to the last letter, it must be the actual letter, because we will check that when before we get to this point. So if we get to the last letter and it was the right letter, we will return 1. So that's our base case. If we ever get to the last letter, we're returning 1. We found one one word. Aside from that, if we're not there, we're going to need some count to hold our our total number of ways we can find our word starting from this point at this index. So I'm going to say, hey, what if we keep going straight? What if the next thing is in bounds? So that would be R plus R shift would be the next guy we're looking at. And C plus C shift. So if that's in bounds and the thing there is actually the next letter, and if the grid at R plus R shift and C plus C shift, if that's equal to the next letter at the index +1, then we will recur on it. So that'll be index +1 will be our next index. Our next position of the letter we're looking at will be R plus R shift. And C plus C shift. And then our current direction markers. Our row, we're moving R shift each time. Our column, we're going C shift each time. And this you'd think might be false or something because we're continuing on the same direction, but it's actually going to be whatever it was before. Like R shift and C shift are going to change if we turn like at some right angle. And so maybe we've used our turn at this point, maybe we haven't. So it'll just stay whatever it was before. And then we got to try our, by the way, we're taking the result of this and adding it to count. And then we'll basically do the exact same thing 3 more times. Or sorry, 2 more times for a grand total of 3. And then return whatever our count is. However many ways we manage to find to make, find the letter. Find the word in the grid. So this is one turn. So this is assuming it turned in one direction. This is going to be a little confusing. It'll take some thinking. But one way to make a right turn is to maybe have the column move by the row shift and have the rows move by negative the column shift. So think about that. We're shifting where we used to go row-wise and adding that to our column, and we're shifting what we used to do to our column and subtracting that from our row. That will be a right turn. Try it with all different possible directions, and you'll see that that works. And so I'll just continue the same thing. It's basically the same. By just now turning right. We will also need to have, we must not have used our turn. So for all these guys, we must not have used it. Actually, I'm just going to copy and paste this one because it'll be more similar. So if we have not used our turn, and if we turn at a right angle in one direction from here, we see the next letter. We have our count be up this recursive call on it. Same thing as before, but we got to do kind of the minus column shift and plus the row shift. And in this case, we have used our turn at this point. We must have used our turn to be here. And then we'll do basically exactly the same idea, except we're just going to change if we're adding the row shift or the column shift. So these kind of switch. So in this case, the row's adding the column shift and the column subtracting the row shift. So we just shift all these guys. This is if we turn right in the other direction. Again, think it through and see if you can make it make sense in your head. And then I think this will work. This should be it. Should be all you need to make it work. So as a quick recap, made a scanner, got in all our data. I used char arrays. I made a lot of my variables static, so I wouldn't have to use them in my methods. I could also have made them arguments in my methods, and that would have worked fine too. It just would have been a little more awkward. And then, yeah, taking all your data. Again, I used a char array with a little trick here, given that it's supposed to be space separated. And then I made a count variable to hold how many times I managed to find the word in the grid. I loop through all the different indexes in the grid and look for the first letter. If I ever find that first letter, I look all around it with a shift either up and around it for the second letter. This you don't actually need for this problem, but this is just saying, hey, no point in looking at the zero shift for the second letter. So you got to have shifted at least in some direction to find the second letter. And the new spot we're looking at for the second letter actually exists. We're not along an edge and it doesn't exist or anything. And that that new spot actually is the second letter. If we do that, we start adding to our count by calling in a recursive method from there. And then our recursive method is just, hey, if we ever get to the last index of the word, we return 1 because we found one way to get to the last index. Aside from that, we create a count. And then, hey, if we can keep going in the same direction, if it's in bounds and the next letter is the next letter in the word, then we call recur on that spot. We increase our index by 1. We shift our row and column position by the appropriate amount. Our row and column things stay exactly what they were. Oh, I screwed up. I need to fix this. Remember, this was like my new row shift should be negative my column shift from before. And my column shift should now be my row shift because I added row shift to my column to get here. And then this is basically the same thing, except the other one is negative. So I'm flipping my row and column shift and making the other guy negative. All right. So anyway, this guy is just calling the recursive method on the next letter if I keep going in the same direction. This is checking one direction I can turn right, again by switching which one is my row and column shift, making one of them negative. Think that through, see if it makes sense how that makes a right turn. Checking that the next letter, if I go in that direction, is actually the next letter in the word, and then recur on that with everything moved over, and I've used the turn at that point. And this is just checking a right turn in the other direction. And by right turn, I mean 90 degrees, not left, right. And that will probably work. Feel free to sign off here. I'm just going to double check it on Damage. To see I'm not leading you astray. Oh, well, it doesn't work. It should mostly work, but I feel like it might be input. It says it's space separated, but I feel it might not be. Oh, actually, let's try it out. I forgot one very important point. I forgot to actually return an answer. That is kind of important. There we go. Nice. All right, so that's how you do it. Thanks for listening. Hopefully this helps all you guys working on Word Hunt.